Hello, everyone. This is Joe Leon, your host for the Micro Focus AI podcast series. Today, we're very excited to have our guest, Stefan Zhu, joining us. And now, before we go to the topic, Stefan, we'd like to get to know you a little better. And you're the CTO for our behavior analytics within Micro Focus. But before you even get to the topic here, maybe we can learn a bit more about you, and maybe you can let us know how you got started in AI in the first place.
Sure, Joe, and it's a pleasure to be here. I've always been into analytics, and I have a background from my school days in analytics. So I have a graduate degree and a postgraduate degree in computer science and human physiology and computational neuroscience and biomedical engineering. Essentially, I couldn't decide between biology or computers, so I just continued to do both. So I've always been interested in the application of computer science and mathematical methods to solve, in this case, biological problems. That fascination and interest ultimately led me to look at technologies like statistical learning and neural networks, which got me my first job at Cognos, where I helped build a data mining program, and then eventually a series of other analytical programs, everything from data mining to neural networks to dashboarding to semantic search to big data analytics to visualization in cloud, kind of all in the new product space for Cognos and then IBM and then now at Interset and Micro Focus.
Excellent. So what do you do as the CTO for behavior analytics at Micro Focus?
I am and continue to be fascinated by how important the problems in the security space are, but how much of an opportunity there is to apply mathematical methods to help solve some of those problems. I think my background in the application of math helps me sort of see opportunities where I think sometimes we don't even realize that there's a way in which we can optimize something or make something a little bit easier, especially in the case where the problems are so severe in cyber and they're so important and it feels like we're constantly under attack. Any little edge that we can give the good guys, whether it be a new algorithm or taking advantage of a recent new mathematical discovery that maybe was applied in other industry sectors but hasn't yet been applied to computer science and in cybersecurity, I think that's where I see my role in the broader Micro Focus behavior analytics division.
Yeah, it's kind of like, looking for best practices that can be applied, right, to what we do here. And so presumably you talk to a lot of customers and other technologies in the industry, right?
Absolutely. And it's always a pleasure actually when I am able to talk to our customers. That's where I learn the most about how we can sort of help their day-to-day lives. Honestly, my background, as you just heard, it's really not security. I'm not a security guy, but I think I am enough of a math guy, and I'm learning enough about the security space that I can sort of help draw these connections between these two worlds.
Yeah, I love it. I've watched one of your podcasts or interviews or webinars. You mentioned that, you use mathematics to catch bad guys, right? And I love it, right? This is, using science and math to come together and find people that are going to cause harm to your company. So and that makes a lot of sense. So continuing on that point here, would love to hear from your perspective, what exactly is AI for cybersecurity?
That's a great question, Joe, and one that I think I want to sort of split that into two parts. So let's first talk about what AI is, and then we can talk about AI in the context of cybersecurity. And I'll try and be pretty brief, but I think this is actually pretty important for the audience because AI is such an overloaded and sometimes misused and misunderstood term There's a lot of market buzz around AI, but I just want to be super clear. And the best way I can think of explaining what artificial intelligence is by comparing it to something that you and I and the audience would already be very familiar with, which is normal, everyday human intelligence. So if I think about what makes a human intelligent, I would say that there are 5 broad categories of things that we do that demonstrate human intelligence. Category 1 would be sensing and perception. We see things, we can perceive things around us. We translate in our brains the photons that impact our retina into things like objects and edges and items being in front of others. So if we think of that as sensing and perception, then there's actually artificial technologies that correspond exactly to that. And you've heard these terms before. There are terms like NLP, natural language processing, speech recognition, visual recognition. These are the things that Siri and Alexa do. These are the things that YouTube does when it tries to scan videos. So there are technologies in the AI world that do sensing and perception. So that's category 1. Category 2 would be on the output side. So if sensing and perception is input, then there's an aspect of human intelligence which is on the output side. So the way we interact with the world around us, the way we communicate to other human beings, those are actually legitimate indications of human intelligence. So in the world of AI, these are technologies like robotics, navigation systems, speech generation, and so on. So there are, again, very well understood intuitive technologies in AI that correspond exactly to the second category. I'll just quickly sum up the 3 remaining categories because they are related to the processing that happens between the input and the output of humans. So those 3 categories in my mind would be knowledge and memories, decisions and inferences, and learning. So knowledge and memories, this is all about how humans remember things and they translate experiences into information and knowledge. And again, in AI, there's a set of technologies that we give names like knowledge representation, ontologies, graph databases, whose job it is to do those aspects of human intelligence, convert information into some sort of representation that can be stored in a computer. Decision and inferences, this is how we can sort of make good conclusions or optimizations in our brains. And again, technologies like prescriptive analytics, optimization, decision-making, decision trees, those are all technologies that we have in the AI toolkit to be able to emulate what we know as decisions and inferences in human intelligence. And last but not least, very dear to my heart, of course, learning. You're not really a good example of human intelligence if you aren't able to show some sort of learning. And there are different types of learning. There's learning that we learn at school where we're given a very specific set of instructions or an algorithm, like here's how you do arithmetic, or here's how you do long division, right? So there's that type of learning. There's also learning that we do on our own. So there's no teacher giving us explicit instructions. Instead, we're learning by examples, we're learning by observation. So just as we said, human intelligence and learning is something that we understand intuitively, there are technologies that we do for our AI that correspond exactly to that. So when we have a teacher that tells us exactly what to do, that's just an algorithm. And we know that software is very good at that. But when software learns by itself, so no one is giving in explicit information and steps, then that is what we now know as machine learning. So machine learning is basically just learning by example or learning by observation. So there are techniques that allow a computer to be able to learn without being told exactly what the steps are. And that's where technologies like neural networks and deep learning and regression trees and CART and linear regressions, that's where that all comes to play. So that was a very long answer to your question.
No, this is excellent because you touch on something that is super hot too, right? Machine learning, you just mentioned as a branch of AI, yes. And I think what you just talk about is essentially unsupervised learning, right? So, just being able to make the observation and derive concepts by just learning from the data. And I think that is a very exciting part of machine learning, and be able to do that. And
that's right. And so if AI is just a collection of technologies, then all we're doing is applying those technologies in the context of cybersecurity. So to me, AI in cybersecurity, which was the original question, is very simple. All it is applying these techniques for the goal of automation in the context of solving and helping out with cybersecurity use cases.
Yeah, I think this is really exciting, because at the beginning of this, you mentioned about the input side, right? You mentioned about speech recognition, image recognition, and all that. And I was actually talking to our CTO of unstructured data analytics yesterday, and that's David Humphrey, whom I'm sure. And on the data analytics side for unstructured data sources, there's a lot to do with the input aspect of it. So I'm sure there's going to be quite an interesting collaboration potentially for you and Dave too, on working on how to actually leverage, the various technologies together. And that could be a future topic for a podcast if both of you come in and have a joint discussion together. So it's just very interesting that how some of the pieces can come together, right? And so without digressing too much, just going back here. So now we understand what AI is for cybersecurity, and I think it's important for us to kind of touch on. Okay, we've heard a lot about AI. There's a lot of attention given to AI. But why should we care as cybersecurity professionals? Why should we care about AI? Why is that important for us? Maybe you can help us understand that a little. That'd be great.
The reason that we should care about AI in cybersecurity is very simple. You talk to anyone that manages a SOC, a Security Operations Center, and they will tell you that there is today a human capital crisis. There are not enough humans with the right skills and experiences for them to sort of staff up their SOC centers to be able to meet the demands of the attacks that they are suffering from. Quite frankly, there are far more bad guys than good guys right now. And it's also a very unfair game. Only one single attack needs to succeed and the bad guys win. For the good guys to win, they actually need to successfully defend against every attack. Yeah. And there are a lot of attacks. I just read a study by the University of Maryland where just in their own environment, they determined that that hackers attack their system every 39 seconds. So if you do the math, that works out to over 2,000 times a day. So there's a lot of attacks happening all the time. There's not enough humans. So what's the best way we can help them? Well, if AI is, as I just said, nothing more than automation to help replicate some of the things that we can do humans, then basically what we're doing is we're applying AI technologies in order to do things in the cases where we don't have enough humans that can do it. It's not that AI is trying to do something that humans cannot. That's really not the case. It's more the case that you'll just never have enough humans to be able to meet the demands. And the good thing about AI is that, hey, math never needs to sleep. Math can be working 24/7 to try and detect attack patterns. It could be exhaustively combing through billions of log file entries every single day, exhaustively looking at every single combination of events together in a way that would be humanly impossible to do just because you don't have enough humans. Yeah. That's the key reason I think why we should care.
Yeah, it's absolutely true. Especially these days, you talk about the increasing number of attacks. Attacks from different places of different nature. It's quite overwhelming, isn't it, for human alone to be able to address these. So I think you're absolutely right. Having a 24/7, 365 capability to do that's going to be really important for the security operators. So with that in mind, maybe what we can do is to kind of hear some real world examples, because if you've worked with customers extensively, you talk to a lot of people in this particular area, maybe you can share some examples actually using AI in cybersecurity that the audience would learn from. That'd be great.
Would love to, Joe. And I do have the pleasure of talking to a lot of customers that have implemented various AI systems, including Interset, into their environment. And we have definitely found some very interesting things. So I'll give you maybe a couple of real world examples. So one was at a large US financial institution where I guess I'll tell you the story here. One of their employees came in at 3 o'clock in the morning, 2 days in a row during a weekend, which was a specific activity pattern that was very unusual for that particular employee. And also printed off just over 350 documents over the course of 2 days.
Wow.
In this case, this was something that was very sensitive and very concerning to this particular financial institution. This is a good example of something that was detected immediately by the analytics. So as soon as this happened, as soon as the employee came in and 2 days in a row at this unusual time, as soon as the employee started engaging in printing an unusually large volume of documents for this particular employee, that's an example of what we call an anomaly. And so that anomaly, there are very statistical methods to be able to detect and quantify those anomalies. Those detected and serviced by the analytical systems in place, and automatically notified the security teams, and an investigation was launched as a result of the review process that was kicked off by this. It's also a good example of something that certainly could have been done by a human, to our earlier conversation, Joe, but it would have been sort of really difficult. This was a very large US financial institution. So think hundreds of thousands of employees across the banking system. I want you to also think about that while it was unusual for this one particular employee to come in on the weekend, it's not unusual for a bank teller to be working on the weekend. While it was unusual for this one particular employee to print 350 documents, perhaps an administrator assistant at the bank prints hundreds of documents every day, all the time. So there's a level of granularity and precision that is very difficult to scale up to a human team, right? It's very difficult to imagine a team of even 100 humans becoming familiar with every single employee. But if you have an AI system that could sort of analyze everyone's pattern so that you can detect when the pattern of one specific individual starts to deviate, that's how you can sort of scale up your detection system using AI.
Indeed, this is like, as they say, finding the needle in the haystack. Yeah, but you need to find that needle because that's going to hurt you. And
that's right.
This is kind of an insider threat situation that is happening all over the world. And you're absolutely right in terms of multinational, global companies, big operations.
That's right.
It doesn't remove the need to find it, but it does increase the complexity of finding it, right? That's why AI can come in and play a big role.
Exactly. And insider threat is a good example of the types of subtle behaviors that are most effectively detected using AI. As opposed to sort of large crass behaviors like a distributed denial of service that can be more easily detected by sort of a traditional SIM-based, rule-based method. Right. I'll give you another example maybe of a subtle attack which is not insider threat. So I'll give you an example of an external APT-based attack.
Right.
This was at a US-based software vendor, so a high-tech firm. And they had one of their VPs where the analytics realized that the machine was authenticating locally an unusual number of times for that user. Now, when you run a script that performs a local authentication, that would be an example of something that would generate this type of behavior. However, in this case, this behavior is while perfectly normal for, say, an engineer to be running scripts and doing local authentications, it is very unusual for a VP who never runs these type of scripts to all of a sudden demonstrate this type of behavior inside their Active Directory feed. So again, this is something that was unusual at a level of precision for this one particular user across this large security software vendor company. It was discovered automatically by the AI within 24 hours of the beginning of the behavior, and immediately resulted in an investigation. It ended up being an APT, and this particular company was obviously very happy to have discovered this, especially given the sensitivity of the information that the VP had access to.
Yeah, that is a pretty interesting example as well. I guess it runs the gambit, doesn't it, in terms of there's various ways to use AI, but I think it doesn't really matter what kind of attack, the nature of the attack, because you're just looking for the behavior, the anomalies, right, in the behavior. So it really cuts across different kinds of threats. It's just a matter of just looking into the data, finding the unknown, and be able to pinpoint it in a very timely fashion so you can mitigate the threat of that particular incident.
That's exactly kind of the beauty and the promise of using unsupervised machine learning and anomaly detection in particular as a way of helping out the sort of poor person who isn't always able to define in advance what an attack looks like. Because that's always been going to be the case. You use the term unknown unknowns, and that's kind of perfect for anomaly detection. So you don't have to define in advance what bad looks like. If you can make the fairly reasonable assumption that any sort of unusually large disruption to normal behavior, whether that's the behavior of a user or the network patterns or the IO traffic patterns or the process launches or the way IPC happens, or the way data flows, any disruption to any of those patterns, if they start to deviate significantly from what is in a normal, healthy ecosystem, then that is worth your security team's time to investigate. Then if you're good with that assumption, then this can be a very effective way to detect unknown unknowns.
Precisely. Now, you did mention a little earlier that, there's SIEM systems out there. You've got obviously a lot of people running SIEM already. And can you give us some insight on how the behavior analytics can work in concert with the SIEM system to counter threats in the cyberspace?
And that's also a fantastic question, because you're exactly right. Most of the audience out there, they probably already have a SIEM. So they might be asking themselves, okay, this all sounds great, but am I now sort of replacing my SIEM with a completely different system that is brand new to me? And the answer is, of course, absolutely not. This is not a replacement for your SIEM. So I want to make that super clear. What this is, however, is a new set of technology that is very powerful, that can take advantage of all of the data that you're already collecting in your SIEM, take advantage of all of the rules and policy that you've already got in your SIEM, but it is actually able to make them smarter. So think about being able to not only define what bad looks like using the rules and policies in your SIEM, but now you can add to that by saying, also tell me whenever someone does something at an unusual time of day, whoever they are, or tell me when one of my systems starts to exhibit unusual network traffic, or tell me when some process on one of my endpoints is an unusual process for that endpoint, because that's probably some sort of APT attack, right? So you're essentially making your existing SIEM system smarter by adding to it, by augmenting it with these technologies.
Yeah, so it's very complementary. It's one of those situations you have 1 + 1 equals greater than 2, right?
That's right. Any number greater than 2.
Yeah, that is fascinating. Now, so if we look at the situation where the AI is getting a lot of traction in various domains, right? We're talking about cybersecurity here. So if you can look forward, what do you see from a technology perspective, and what do you see the future is going to be like? What's the evolution of this in this particular space?
I'm so excited for the future, and actually, this is one of the reasons I'm so excited to be part of Micro Focus now, which gives me access to much more than I was able to do by myself just as Interset. So the future is bright for two reasons. One is more math, and the other one is more data. So if I focus on the math first, I just talked about a set of things that we detected using AI. But really, given my original explanation of what AI is, I just gave a bunch of customer examples that only used one small fraction of AI, specifically unsupervised anomaly detection, which is a subset of machine learning, which we now know is a subset of AI. So there are all these other techniques like optimization, simulation, forecasting, optimization under constraint, causality models, probabilistic models, recursive Bayesian estimation methods, context, socio-demographic annotations. There's almost been a renaissance in mathematics, especially on big data sources in the past 10 years. And we've really only scratched the surface in applying those mathematical problems to the context of cybersecurity. So that's more math. More data is actually also hopefully equally exciting as well. As part of Micro Focus, we have access to more data than ever before. Our customers have the ability to access more of their relevant data than ever before. We've got data coming in from mobile devices and from the cloud. We've got social networking data. We've got open data systems and IOCs. We've got all kinds of information that all are already being collected and censored. We've got IoT now that we have to sort of worry about. For me, all of these data sources is not really a problem. It's an opportunity where we can apply these various mathematical methods to help increase the security coverage for all of these potential threat surfaces that might become under attack. And the more data that we can sort of automatically correlate together, as you know, if you're a SIM user, the more context that you have, the less noise your ultimate system can have, because you really need that additional context to be able to sort of weed out the true positives from the false positives. So for me, the future looks fantastic, because once you have more data and once you have more math, not only can we just identify the straightforward threats like some of the examples I've given you already, but we can answer some of the more interesting questions for cybersecurity experts, not just what happened and what's the risk and what happened in the past, but very interesting questions like, how can this threat be contained? How could we have prevented this? What's going to happen next? What's the best possible response out of all the possible responses to this one specific threat? And how can we do that in real time? So all kinds of really interesting use cases that we can now support and answer.
Indeed. And you mentioned more data, more math. So what is your thought on the more processing power area? The GPU, for example, is getting more and more attention in the AI world for delivering the processing power needed. Thank you, gaming industry, right? So driving that forward. So what's your thought on the more processing power to support the more math and more data? What's your view on that?
Oh, that's been absolutely key for the success that we've had in AI in the past 5 years. One good example is deep learning is nothing more than neural networks from the 80s, but now applied at scale. It's the exact same algorithm. It's just that back in the 80s, when neural networks was first developed, we only had the ability to process, let's say 10,000 rows of data. We had limited numbers of cores that we could sort of run information on. We had maybe the Department of Defense that had a couple of really big mainframes, but
Mm-hmm.
that essentially limited how much processing that we could do and how much data we could analyze. Now with the advantage of GPU hardware acceleration, but I would also add to that the cloud, where all of a
Mm-hmm.
sudden, for the first time, we can easily sequester hundreds of thousands of machines, literally, and use their compute for short bursted periods of time. That is only economically feasible with technologies like GPU and cloud. And we're kind of experiencing the renaissance as a result of that. So absolutely, those advantages, that evolution that you described around hardware acceleration and cloud really is giving us the opportunity to be able to do more math on more data than ever before.
So with so much to do, so much happening, so naturally it'll be interesting for a lot of people in terms of a career option. Yeah. So since you spend a lot of time in the AI world, what is your view looking forward for people looking into pursuing a career in this space?
AI is one of the hottest spaces just in general. I think a couple of years ago, Harvard Business Review called a data scientist the sexiest job ever. I've never been accused of being sexy before, but I won't take it. So that's fantastic. At the same time, security is incredibly understaffed, and a security job, even if you don't have a background in security, super attractive. There's lots of hiring going on there. I would say the opportunities in security are also very high up there, if not in the top one or two. So obviously for me, the combination of AI in security is perfect. The job opportunities and just the opportunity to grow in your career, and also at the same time have a really incredible big impact is second to none. This is why I got into this space. I got into this because not only did I feel that I could sort of have a big impact, but this is a set of problems and challenges that this entire industry faces together that really, if we can sort of even scratch the surface, we can do societal good, and we need to do it together. If I can get out of my soapbox a little bit, this is unfortunately an area where, at least right now, sometimes it feels like the bad guys collaborate more than the good guys, if you know what I mean. Like the bad guys, the hackers, they're on the dark web, they're sharing scripts, they have toolkits that help each other do hacks. And sometimes I feel like the good guys, the few of us out there, we're not sharing enough knowledge, we're not teaching each other enough. And so absolutely, I think not only is this good for your career, I think it's just good for everyone in this space to continue to work with and share information as much as possible.
Yeah, it's almost like, the cyber heroes, right? Going out there and protecting people. And I mean, this is something that is so connected to the well-being of a society. Yeah. And I think even at the national security level, right, cyber security, cyber threats are one of the key areas that people are looking at the government level across the world. So this is a really fascinating time, having the two waves going to come together, one security, one AI, right? It's a truly a world where the opportunities are endless for people who are thinking about it. So this is great. Now, with people getting more and more interested, or people who need to get more information, more education about this, what's your recommendation in terms of where they can learn more about these opportunities and the technology itself as well?
There's a lot of information out there, but let me maybe point you to a couple of my favorite information sources. So if you're a young millennial and you like videos, there's a lot of content that we have on YouTube. So if you go to YouTube and just search on the word Interset, INTERSET, you'll find our YouTube account. And there's tons of really great cartoons and interviews and demonstrations out there. We cover everything from the AI technologies that underpin our approach to very specific use cases, to even some product demos, if that's something that you're interested in seeing how this all works in action. That's one source for you. If you're more of a reader and you like to consume technical white papers, then the interset.com website, which also can redirect you to the right section on the Micro Focus website. There's actually a lot of white papers and blog entries there where myself and various members of the Interset data science team we were able to go into a little bit more detail, a little bit more math, just on the various techniques and technologies that we found to be very useful for detecting threats and the AI space and the way we think about AI and data science. And lastly, if you're an old school guy like me and you just love a book so that you can sort of dog-ear the book and put bookmarks in it and mark it up, there's an excellent book, which I have no affiliation with, but I'm a big fan of it. It's called Data-Driven Security. It's by Jay Jacobs. And it's just a really nice, very easy introduction, especially if you have a background in security, but not in analytics, on how you can apply various analytical and visualization methods for very specific security use cases. And it's just a nice place to start.
Excellent. Wow, I can't believe, we've spent a fair amount of time here, but I guess time flies when you're having fun. I learned so much today, Stefan, and I'd like to really thank you for taking the time out of your busy schedule to talk to us and share your thoughts and the real-world examples that's happening right now, right? And so much information, so much to learn. So we'd love to have you back again. So other topics we'd love to be able to have a chat with you on in the future, if that's okay with you, Stefan. And but with that, we would like to close. I'd like to thank the audience for joining us here in this podcast, and I look forward to having another one in the future very shortly. Again, with this, I will let Stefan go. Thank you, Stefan, for your help here and for all the great information you share with us.
Absolutely. Thank you so much, Joe.